Are we alone in the universe? This question has been in the minds of scientists for centuries, capturing the imagination of people everywhere and driving countless other questions of the unknown. Many scientists believe that Earth isn't the only place in the universe to host life. But considering just how big the universe is, with an estimated 2 trillion galaxies, perhaps then a better question is, are we alone in the Milky Way? According to a new study published in the Astrophysical Journal, researchers from the University of Nottingham suggest that the Milky Way galaxy is home to 36 communicating intelligent alien civilizations. But how did they arrive at this very specific number? They say the estimate is actually conservative, and it's based on the assumption that intelligent alien life forms on other planets in a similar way to how it does on Earth. The scientists assume that Earth is not special. If we imagine a planet much like ours, orbiting a star like our Sun, hosting a civilization that develops technologically in a similar way to humans, and under the assumption that it takes 5 billion years for intelligent life to form, then there would be at least 36 Earth-like civilizations in our galaxy. Previous calculations of alien life have been based on the Drake equation, which includes 7 factors needed to find the number of intelligent civilizations, but the estimates have been extremely broad, ranging from 0 to a few billion civilizations. With this new method, the researchers refined the equation using new data and assumptions. They found that there are likely between 4 and 211 civilizations, with 36 the most likely number. However, finding these civilizations is another issue entirely. Scientists said they would be thousands of light years away. But let's begin by exploring Proxima Centauri b, the nearest exoplanet that may potentially harbor alien life. This intriguing world orbits within the habitable zone of Proxima Centauri. The habitable zone, or the Goldilocks zone, is the region around a star where the conditions are just right for liquid water to exist on a planet's surface. In this zone, the temperature is ideal, neither too hot, which would cause water to evaporate if the planet were too close to its star, nor too cold, which would cause water to freeze if the planet were too far away. This temperature range offers the potential for life as we know it to thrive. Proxima Centauri b is very similar in size to Earth, with a mass of approximately 1.17 Earth masses. This suggests it's only about 10% larger in diameter than our world. The planet is likely tidally locked, meaning one side of the planet always faces the star, receiving constant daylight, while the other side is in perpetual darkness. There could be 3 distinct climate zones due to tidal locking: a hot, sun-facing side, a cold, dark side, and a potentially habitable twilight zone in between. If alien life exists on Proxima Centauri b, the unique conditions of being tidally locked could lead to extraordinary adaptations. On the perpetually lit side, life forms might have evolved to withstand continuous exposure to the star's radiation, possibly developing protective mechanisms or using the constant light to their advantage, perhaps through photosynthesis-like processes. On the dark side, organisms could have adapted to the extreme cold and constant darkness, possibly relying on geothermal energy or other forms of heat different from starlight to survive. Now, if intelligent alien life exists on Proxima Centauri b, the implications would be astonishing. First, it would suggest that intelligent life is likely common throughout the galaxy. Considering the Milky Way hosts an estimated 400 billion stars, the odds that the only 2 planets with intelligent life happen to be neighbors would be astronomically low. Second, the discovery could provide clues into the nature of space travel among extraterrestrial civilizations. If these neighboring beings have not yet made contact, it could indicate that even for a more advanced alien society, interstellar travel is an even bigger challenge than we thought. Or it might also suggest that they are technologically less advanced than we are, positioning humanity as the potential first interstellar visitors. In this scenario, we would be the aliens arriving on their planet. However, before we get ahead of ourselves, It's crucial to remember that these ideas remain purely speculative. The existence of extraterrestrial life, let alone intelligent life beyond Earth, has yet to be confirmed. Another intriguing candidate for hosting alien life is Kepler 62e, a super-Earth located about 1,200 light-years away, and here's why this exoplanet stands out. It's approximately 1.6 times the size of Earth, which suggests it might have similar mass and gravity. It orbits within the habitable zone of its star, which is smaller and cooler than the Sun, creating potentially ideal conditions for liquid water. There's a strong hypothesis that Kepler 62e could be a water world, covered mostly or completely by oceans. This could mean a variety of aquatic life forms might exist there. If Kepler 62e has an atmosphere, it's thought to be very cloudy, warm and humid, extending to the polar regions. If it truly is a water world, this could make the development of civilization as we know it more challenging, yet it does not eliminate the possibility of advanced marine organisms. The concept of life on Kepler 62e is still speculative, but it's a top candidate in the search for alien life due to these promising characteristics. However, its great distance from Earth means that our current technology doesn't allow us to study it in detail to confirm these possibilities. Gliese 667 cc is another super-Earth with the potential to host alien life. The planet has a radius 1.7 times that of Earth and is about 23 light-years away. Gliese 667 cc is part of a triple star system, which could mean that if you were standing on the planet, you might see 3 suns in the sky. Its host star is a red dwarf with about a third as much mass as the Sun. As a result, stars like Gliese 667c can live up to 150 billion years, or 15 times longer than the Sun's lifespan. Even if alien life does not currently exist on Gliese 667 cc, the system's potential lifespan of 150 billion years offers an extended window for life to emerge and evolve. This prolonged period of stability far exceeds that of our own Sun, providing more than enough time for complex life forms to develop at a later stage in the planet's history. Gliese 667 cc is among 5 other planets that orbit the red dwarf star, 3 of which are within the habitable zone. This makes this system a prime candidate for the potential of alien life. However, whether life actually exists, there remains a mystery, as we currently lack the technology to detect life at such a distance directly. The study of exoplanets like Gliese 667 cc helps astronomers understand the conditions under which life might arise and how common habitable worlds might be in our galaxy. Kepler 22b is another fascinating alien world categorized as a super-Earth and is about 2.4 times Earth's radius. The planet's composition is still a matter of debate. It could be covered in a vast ocean, or it might even be gaseous. But if it is an ocean world, it's possible that life could exist in such an environment, as suggested by some scientists involved in the Kepler project. The idea of an ocean world is particularly interesting because it opens the possibility of aquatic life forms. However, with a staggering distance of about 640 light-years separating us from Kepler 22b, it's currently beyond our reach for direct exploration using today's technology. Now picture an advanced alien civilization on Kepler 22b, peering through sophisticated telescopes aimed at Earth. What they'd be observing is our planet as it was back in the year 1384. They would see Earth's medieval era. This delay is due to light, the fastest thing in the universe, taking 640 years to travel from our world to theirs. Yet even as vast as 640 light-years may seem, it represents less than 1% of our Milky Way's staggering breadth of 100,000 light-years. So far, our exploration of exoplanets has barely touched a tiny fraction of the potentially habitable worlds that might exist out there. Drawing on data from the Kepler Space Telescope, estimates suggest there could be up to 300 million potentially habitable planets within our galaxy alone. Considering this, Estimating only 36 potential alien civilizations in the Milky Way seems extraordinarily conservative. Now let's imagine for a moment that each galaxy hosts just one single civilization. If true, with the estimated 2 trillion galaxies in the observable universe, there would be a minimum of 2 trillion civilizations out there. Faced with these numbers, it's humbling to realize that our civilization might just be a tiny speck, as viewed from the broad cosmic perspective. As we gaze out into the stars, we must ask ourselves, what legacy will we leave behind in this cosmic sea of possibilities?